Hi students, hope you are doing good. Okay, see, in this video I'm going to learn about the particular reaction called means the reaction which is come under preparation of alcohols. Okay, the reaction is hydration of alkenes to alcohols. Okay, why we need to learn this reaction? Because it is an industrial process. Okay, you see, industrial process means the alcohols like ethanol, CH3 CH2OH. Okay, this is a very good solvent. Okay, good solvent and an reagent for many chemical reactions. Okay, that's why we need to learn this particular reaction, that is preparation of alcohols from hydration of alkenes to alcohols. Is that clear? See, before we get into the reaction, okay, we need to learn what is hydration, what are the exact meanings of these words. Okay, what is meant by hydration? Hydration is nothing but hydro. What is hydro? Hydro nothing but water. Okay, hydration is addition of water. Addition of water. Is it clear? Hydration is addition of water. Where you are going to add? See, you are going to add water to alkenes. Is it clear? That is hydration of alkenes to get alcohols. But see, if you take just water and alkenes, the reaction will not move forward. Okay. See, this reaction is carried out in the presence of the catalyst. Catalyst. Is it clear? What is the catalyst? Acid is an catalyst. Acid is an catalyst in this reaction. Okay, acid is the catalyst in this reaction. Acid acts as the catalyst in this reaction. So, what is the general reaction? What is the general statement we can make? That is, acid catalyzed hydration will acid catalyzed hydration of alkenes to alcohols. Is it clear? This is the general statement we can make. Okay, if we conduct acid catalyzed hydration reaction on alkenes, you will end up with getting alcohols. Okay, what is the general reaction then? You see, if you take any alkene, okay, this is an alkene. See, what is alkene? The in between two carbon atoms, one at least double bond should be there. Is it clear? This is an alkene. See, you are going to add water molecule. Is it clear? See, you are going to add water molecule in the presence of acid. Okay, you will get what? See, you know this water molecule can split as OH minus and H plus, right? Okay, you will get an alcohol. You see, alcohol. You see, this negative part can go to this carbon, can go to this carbon. This can also go to this carbon, can also go to this carbon. Why? Because this alkene is symmetric. Okay, what is symmetric? If you draw one line between the center of the molecule, if this is the center of the molecule, if you draw one line between the center of the molecule, that line should cut the molecule in such a way that the two equal parts contain same number of carbon atoms and hydrogen atoms. You see, if you put hydrogen here, there are two hydrogens here and there are two hydrogens here also. One carbon this side, one carbon that side. But this is the symmetry of the alkene. Okay, you see, so this OH minus can attack this carbon, either this carbon. Okay, you see, in this reaction I attach OH minus to this carbon and H plus to this carbon. Okay, you will get alcohol. Okay, this is the general reaction. You see, if you take an example, CH3CH2OH, sorry, CH2 double bond CH2. This is an alkene. What is this name called? Ethene. 2 carbon atoms. Okay. If you add water in the presence of H plus, nothing but acid, okay, you will get what? CH3CH2OH. Is it clear? See, this particular reaction, acid catalyzed hydration reaction, okay, see here H plus is the catalyst, nothing but you are going to use any of the acids such as H2SO4 or phosphoric acid. Okay, this can donate H plus ions. Okay, this acts as the catalyst. Is it clear? Yeah. Next, see, this is one kind of example. Okay, if you take any of the unsymmetrical molecules such as CH3, CH2 double bond CH2, what is this? Propene. Okay, if you add water molecule, okay, in the presence of acid, what you will get? What you will get? See here it's a symmetrical molecule, okay, but here the symmetry changes. It's not a symmetrical molecule. See, if you cut here these 1 carbon but 4 hydrogen, there 1 carbon and 2 hydrogen and double bond is there. So what will happen? This OH minus and H plus ions are there. Okay, see here the addition happens according to the Markovnikov's rule. Okay, what it says, the negative part of the adding molecule will attach it to the carbon which is having lesser number of hydrogen. Okay, this is. See, if we look at unsymmetrical alkene, okay, such as propene, okay, what is the propene? CH3 CH double bond CH2, right? Okay, this is contain 3 carbon atoms. Okay, this is unsymmetrical because if you cut here, okay, you see here there are 2 hydrogen atoms, here there are 3 hydrogen atoms. It's not symmetrical, and this part contain double bond and this part contain only single bond. Okay, this is unsymmetrical, unsymmetrical, right? Okay, if you conduct, okay, acid catalyzed hydration, okay, acid catalyzed hydration in the presence of catalyst, okay, H plus is an acid. Okay, see this water splits as OH minus and H plus, right? Okay, you see the addition of this OH minus, okay, addition of this OH minus takes place, okay, according to Markovnikov's rule. Okay, what is the Markovnikov's rule? Here the addition of OH minus takes place in the law called Markovnikov's rule. What is Markovnikov's rule? Markovnikov's rule say the negative part of the adding molecule, this is the negative part, right? OH minus is the negative part. The negative part of the adding molecule will go to the carbon which is having less number of hydrogen. Is it clear? See, this central carbon has only 1 hydrogen, this is having 2 hydrogen, hence the OH minus will attack this carbon and H plus O to this carbon. Negative part go to the carbon which is having less number of hydrogen, positive part go to the carbon atom which is containing large number of hydrogen. Is it clear? Therefore you will end up with getting CH3 COH H C CH3. Okay, this hydrogen will get attached to this side. Okay, what is this? What is this? Propane 2-ol, right? This is an alcohol. Okay, this is the 2 general examples that we can give for the acid catalyzed hydration reaction. Is it clear? Okay, next if we move on to the mechanism, okay, mechanism of this reaction. Mechanism, What is the mechanism of this reaction? Mechanism. You see, this reaction will follow three-step mechanism. Three-step mechanism. Okay. What is the mechanism? What are those three steps? I will explain. Okay, just don't worry. Okay, in simple manner I will explain what carbon will get positive charge or oxygen will get negative charge, what is lone pair. I'll explain detail in this video. Just give concentration, just take down the notes. Okay, take down the notes. Okay, in first step, okay, first step, what happens? What is the first step? I'll just write one sentence and just follow the sentence. Okay, what is the first step? The first step is protonation of alkene to form carbocation by electrophilic attack of H3O plus. You see, just try to understand the statement. Okay, protonation of alkene to form carbocation by electrophilic attack of H3O plus. Okay, the protonation of alkene is happening by electrophilic attack of H3O plus. Then how this H3O plus is formed? Okay, we need to know how this H3O plus is formed. Then how this H3O plus will attack alkene to form carbocation. Okay, this is electrophilic attack of H3O plus on alkene to form carbocation. Okay, before attacking, the H3O plus is need to form, right? How this H3O plus will form? Okay, that I'll show you. Okay, what you are going to take in your reaction, that is water, right? See, always oxygen will have two lone pair of electrons, right? Okay, you see, and you're going to take acid as your catalyst. Is it clear? What will happen? The reaction between acid and water, you see, this is electron deficient, right? You see, this wants electron very eagerly. Okay, this will attack the oxygen atom, which is containing more number of electrons, because this contains two lone pair of electrons. So it will form bond. Okay, this is not the proper way. You see, one positive charge should be there, because oxygen, if the one lone pair of electron is used up by the hydrogen, then it will get positive charge. Okay, this is called hydronium ion. Then what happens? This H3O plus will attack alkene. Okay, you have alkene, right? Then attack of H3O plus takes place. Is it clear? What is this? This is an electrophile, right? Why this is an electrophile? Because it is electron deficient. Okay, this want electron to form stabilized structure. Is it clear? Is it clear? What will happen? This electrophile will attack the double bond of this carbon-carbon. Okay, why this wants electron? This is having double bond because this is electron rich. This is the electron rich side. Therefore, this attacks this side. How this will happen? This hydrogen will attack this. Okay, then it will break this bond and the oxygen atom will get electrons. Okay, what is the product? C, hydrogen, single bond, carbon bond. Is it clear? Next, see, if this electron pair will be donated to oxygen, okay, then what will happen? H2O will form. Then it's happy. It will get 2 electrons, means 2 lone pair of electrons. Okay, but here this carbon atom will get a positive charge because here it is satisfied 4 bonds, but this carbon atom has only 3 bonds, but therefore it will get positive charge. This is called carbocation. Okay, this is the first step. What is the next step? Step 2. Just follow the statement. Okay, nucleophilic attack of water on carbocation. Is it clear? Nucleophilic attack of water on carbocation. Here water acts as nucleophile. What is nucleophile? Electron rich, because your water got 2 lone pair of electrons. Oxygen got 2 lone pair of electrons. Is it clear? You see, this water will attack carbocation. Okay, you know the structure of this carbocation. C. This is the structure of carbocation, right? What you have got. You see, you have water molecule, okay, which is stable because oxygen have 2 lone pair of electrons. Okay, this water will attack, okay, this oxygen, the electron rich water will attack the electron deficient center of carbocation, and then it will form bond. Okay, see, this is the beauty of chemistry. Okay, oxygen, hydrogen, hydrogen, hydrogen. Is it clear? See, here also the 1 lone pair of electron is used up by carbon to form bond. Therefore, it is having only 1 lone pair. Therefore, it will get positive charge. Okay? Is it clear? This is an ion formed in this. Let's move on to the third step. Okay? Step 3. Step 3. What is step 3? You see, you have 1 ion, okay? In step 3, the deprotonation of that ion happens. Deprotonation to form what? Alcohol. What is the ion that you got in the previous step? This is the ion, right? This is the ion. Okay, you see, you have water molecule in your reaction mixture. Okay, you already have water. Okay, what will happen? See, some interesting thing will happen. You see, this bond will break and donate the low pair of electrons, and this come as H plus. Okay, so what happens is COH. Okay, what is this? Alcohol. Where this H plus go to H2O. What will form? H3O plus. That is hydronium ion. Hydronium ion. Is it clear? This is the reaction. Okay. Thank you for watching. Okay, please